All right, welcome MCT4C. Welcome to the end. I think, even though it's only day 71 here, this may be the last lesson of MCT4C. There may be a couple of review videos or something like that, but this is the last new stuff. So let's get right into it. The goal today is essentially to use the properties that we learned about the circle yesterday to solve some problems, and some of them are just goofy circle problems like this, and some of them will try to be applied as well. We'll see. So this first one, we just want to find the indicated unknown, which is x. There's a central angle. There's an inscribed angle. This is the Star Trek theorem that we, as we like to call it, and the property is that this is twice that. So if I want to go backwards, x is a half of 80. And the reason why I can say that is because of this central inscribed angle theorem. Central inscribed angle. And we should be able to state a reason, whether it's, remember what the name of the theorem is, or whether you just sort of in words describe that it like that. Here we've got two unknowns, x and y, and x, you see, is subtended by this chord FE, or the minor arc FE, both ways we think of it. Since it's subtended by FE, and so is this angle, x is just 30 degrees, and they're both subtended by FE. Would be, or inscribed angle subtended by FE. Inscribed angles subtended by FE. That would be the reason. A little bit wordy reason, but still the reason. Notice, well, how do we get y? Well, notice that we got lots of stuff going on here. We got this triangle. This is 30, but if we knew that angle, we could use angles in a triangle. This 5 centimeters, I don't know how we can use that to help us find y, but notice this angle. It subtends DF, and DF happens to go through the center. So what does that mean about y? Well, y is 90 degrees because it's subtended by a diameter. Hooked up to a diameter. And notice this 5 is just sort of irrelevant information. We never used it at all. But notice that we could now start to use trig, for instance. We could find out the length of DE. We could figure out the length of DF using stuff like, well, notice the opposite side and the hypotenuse. We could say, and this is coming, something like the sine of 30 degrees is opposite over 5 centimeters over hypotenuse, and then I can find out what the diameter and the radius or the area of this circle would be, let alone just about everything else in this diagram, just because we know so much about circles. Okay, solving problems. This one's supposed to be fairly applied thing, applied question. Ferd is walking across Cirque following the thick path as shown. So this is Cirque Pond here, and apparently Cirque is perfectly circular. In the diagram, AO, this is 500 meters. So I'm going to draw that on there. That's 500 meters. And the pond is 400 meters across. So this is the center of the pond, and this is 400 meters. So how long is his route? Well, notice it's basically 3 pieces. It's this AB piece, this BC piece, which is an arc BC plus CD. So we got AB plus arc BC plus CD, and we're going to have to use a bunch of knowledge to use this. Now, notice, to continue, we have to make a couple of assumptions. We have to assume that B and C are points of tangency. Otherwise, we've got no idea about any of these angles or anything like that. So we're going to assume B and C are points of tangency. And this would be given in the question, and it will be in the homework. So if that's a point of tangency, what information do we know? Well, that means that this angle is 90 degrees, right? Radius meets tangent at 90 degrees. And same thing over here. That's 90 degrees as well. Well, how do we continue? How do I even know what this length is? Well, notice what I've just built. OB is equal to OC, which is a radius, right? And the radius, so the diameter here is 400. So how much is a radius? A radius is 200, right? That's 200 meters. This here. So I'm going to do that in a different color just to have it stand out. This is 200. This is 200. Well, notice what do we got there? If I wanted to find AB, AB is, we can just use the Pythagorean Theorem, right? Go back to blue here. AB squared plus 200 squared equals 500 squared, just Pythagorean Theorem. And we were able to do that because of this tangent radius rule. Bang, bang, bang on the calculator. Bada boom, bada bing. Dot, dot, dot. And that's equal to 458.3 about meters. And so we got that. And notice also here that since this is 200 and this is 90, this length is 500 as well, right? Because these two triangles here, AOB and OCD, these are exactly the same size. So that means this is also 458.3. This is 458.3. And so what's left? What's left is just to find this arc. And we know this arc is just a fraction of the circumference, right? Well, we need to be able to find out that angle right there. Let me call that x. If I could find x, then I could find out the fraction of the circle, the fraction of 360 that this angle is, and then I could find the arc. Now this is actually a little bit of work here because I want to find that angle there, which is equal to this angle here. Well, how do I do that? I'm going to use trig, right? I've got the adjacent side and the hypotenuse. So if I call that the, maybe I'll put a y in there. Can I put a y in there? Sure. So I call this the cos of y is adjacent over hypotenuse. And do the inverse cos of that. A little trig review. Note to self, start studying for the exam. And I get that that angle is about 66 degrees, around. And so if that's 66 degrees, then I've got this angle, the central angle, BOC. I'm running out of room here. Hopefully you're squishing in. BOC is 180 minus 2 times 66, just because the three of them, the three angles add up to a straight line, right? That's where the 180 comes from. So that's a straight line. And then do that in the calculator. Since 66 is a rounded number, this is a rounded number as well. And I get 48 degrees. Then I'm going to do this last calculation in green for go. I can figure out what arc BC is. Arc BC to the circumference 2 pi r or pi d, however you want to do it, is that fraction of the circle. So the central angle was 48 degrees. The circle is 360, and I can solve for my last unknown here. Cross multiply. Times 2 pi, and the radius is 200, we said. Fire that into a calculator, and you get around 167.6 meters, about. And then finally we can put the bits and pieces together, right? We said AB was 458. The arc was 167. And the last little business, CD, was the same amount as AB. Third walk plus 167.6 plus 458.3, which is equal to about 1.1 kilometers. All right, and I added that up, and it's just over 1,000, meters, rounded to the nearest kilometer. You can figure that out. That's about 1.1 kilometers. I'm going to pick up example 2, the last example of the year, in part 2.